Today I'm going to talk about this problem. It's a variation of the famous two-sum question, but we are given the input as a binary search tree, and we are required to find two numbers in the tree that adds to k. And if there exist such numbers, we return true. If not, we return false. So the solution to the problem is pretty simple, but I wanted to do it anyway. Initially, we are going to perform a depth first search on the tree, and whenever we arrive at a specific node, let's say 5, we are going to perform a binary search, searching for the complementary number for 5. So k is 9, 9 minus 5 is 4. We are going to perform a binary search to search for 4. And the reason why we are performing a binary search is due to the time complexity of the algorithm. So the depth first search, they are all searches, by the way. So binary search is the same as depth first search, except it's an O of n operation, and binary search is O log n, as we all know. So performing a depth first search at each node would result in an overall time complexity of O n square, but replacing it with a binary search would result in an O log n operation. Okay, so at each node we perform a binary search, so the overall complexity is O n log n. Okay, and the reason why I wanted to solve this problem is the way it involves a lot of topics. So I think recursion should be here, because I'm going to solve it using recursion mostly, and we are also going to try to modularize the code. So we are going to have our binary search helper function, and we are going to have our depth first search function. Okay, and this would take a node, and this would take a target and a node. Okay, so let's actually write the depth first search first. Okay, so the base case, if not node, we return true. False, I mean, because eventually you are going to return the answer of the depth first search, which is which we should pass the route. Okay, so if not node, we return false. We would check now if the binary search of k minus node of value and the binary search should start from the root actually, and if this is the case, we return true. That would mean we found solution, and eventually we should continue our depth first search from both the left nodes and the right node. Okay, and this would output the result, which would be either true or false. So whenever we find true, we should return true eventually in the solution function. Okay, so this is for our depth first search, and for the binary search it's pretty standard actually. Also, as usual, the base case, if not node, we return false, and if we find solution, which is target equals to node of value, we should return true, and if target is bigger than the node of value, we should continue our binary search to the right subtree. Okay, So we return the binary search of the target and node of right, okay? And else we return binary search of target and node of left. And there is still one edge case we need to handle, which is what if in this depth first search we had a node and the binary search found the same node. So let's assume this question has a target of 6, okay, and we find a 3 during our depth first search. Then when performing our binary search, it's going to search for the target, which is k minus 3, which is 3. It's going to find the same node 3, but in the question here we are required to find 2 nodes in the tree that adds up to the k, okay? So to handle this edge case, we are going to pass a source node to the binary search function, okay? So it would be source here, and in this condition we are going to add the node does not equal the source, so we should end up with 2 different nodes. What did I do wrong here? If k minus yeah, this should be node, sorry. And here we didn't pass source, and here as well. I guess this should work. Yeah, it worked. So just remember to modularize your code. Make sure you have a proper function naming, and as usual, discussing the time complexity makes the problem easier to solve. Thank you. So what if we wanted to make this improve this time complexity? Can we achieve an O-van? We can see that in this spot we are performing a binary search, which is login, which is efficient, but it can be reduced down to an O of 1 as we are performing our depth first search. If we then find a solution, we might replace all this part with just a set to keep track of already seen elements, okay? So if not node, we return false. If binary search, that would be replaced by if k minus node of value, and seen, we return true. Other than that, we add the current value to the set, okay? This should work. This is my first attempt trying this actually. Yeah, it worked. So that's an oven solution.